What is a star? A star is a very large ball of gas, usually hydrogen and helium, that glows from its energy. Stars are different from planets in that they are self-luminous, meaning they actually produce light. Planets do not do this. The intense heat and pressure within the star actually squeeze the hydrogen atoms together to form helium. Other elements may also form during this process. This is where all elements of the universe were formed. This process, which releases tremendous amounts of energy, is called nuclear fusion. Stars are not burning, rather they are undergoing continuous nuclear reactions. The chart below, found in your science reference table, illustrates the different temperatures and brightnesses of the stars. You can also see a star's life cycle on this chart. Notice the sun is a main sequence star, meaning it is average temperature and brightness, and that is about halfway through its life. The chart that we're going to be using is found in the Earth Science Reference Table on page 15. Characters of stars. The name of stars are in italics, refers to a star represented by a circle with a plus sign in the middle of it. Stages indicate the general sequence of star development, such as early stage, intermediate stage, late stage. Stars are listed on the chart. On the right-hand side of this chart shows that stars are listed by their size, small stars up to massive stars. Stars found in the lower portion of the chart are small. Stars found in the upper portion of the chart are large. On the left-hand side of the chart, we have luminosity. This is the rate at which a star emits energy relative to the sun. The sun has a luminosity of 1. Stars with a luminosity greater than 1, brighter than the sun, less than a luminosity of 1, are not as bright as the sun. The numbers go up by a logarithmic scale, so that a star with a luminosity of 10 is 10 times brighter than the sun if it was the same distance from the Earth as the sun. A star with 100 luminosity is 100 times brighter than the sun. A star with a 0.01 luminosity is 1/100th as bright as the sun. On the bottom we have temperature. Now the temperatures start off with the lowest temperatures over here. Moving over to the left-hand side, the temperatures become greater, and temperatures are measured in Kelvin. You can convert Kelvin temperatures into Celsius or Fahrenheit using this page in the reference table, but we'll get to that later. The color of the star will depend upon its temperature. Stars that are cool have a red temperature. As the temperature increases, the star's color changes from red to orange, then to yellow, then to white, then to blue-white, and then to blue. We'll be filling out the temperature and luminosity of stars together using the star chart. Let's take a look at the first question. What is the color of Polaris? Polaris is found on the chart right here. If I follow this down to the bottom, Polaris would be classified as a yellow-colored star. Number 2, what is the temperature of Rigel? Rigel is located right here on the chart. When I end up drawing a line from Rigel down to the temperature chart, I end up over here, slightly more than 10,000. If this number was 20,000, this number was 15,000. This might be around 11,000 degrees Kelvin. Number 3, how bright? Luminous is the star Sirius. The star Sirius is found on the chart right here. Making a line that goes over to the luminosity part of the chart over here, I see that the luminosity of Sirius is above 10, but not greater than 100, possibly an estimate of 30. Number 4, list 3 stars on the main sequence. All of the stars I've circled here are part of what we call the main sequence, an early stage of stellar evolution. Some of the stars are small, and some of them are massive. Some of them are bright, and some of them are less luminous. Stars like Sirius, Alpha Centauri, the Sun, Barnard Star, Proxima Centauri are all examples of stars that fit on the main sequence. How is Alpha Centauri different from our Sun? Alpha Centauri and our Sun both have the same color, same temperature, but Alpha Centauri is more massive than the Sun and more luminous. Is Procyon b an old star or a young star? Procyon b is a star located in a group of stars called white dwarfs. These are in the later stage of their evolution. They are old stars. Number 7, as luminosity increases on the main sequence, the temperature of the stars. As I go from low luminosity to high luminosity along the main sequence, I travel to the left. As the plots travel to the left, the temperature increases. Number 8, which stage of life is the Sun currently in? The Sun is part of the main sequence, which makes it an early stage. What is the largest star on the chart? The largest star would be the most massive star. The most massive star is Deneb. Number 10, as star color changes from red, to white to blue, star temperature. As we go from red to white to blue, star temperature increases. Number 11, what color are the small stars of the main sequence? The smaller stars in the main sequence are these stars right here, and their colors tend to be red and orange. Number 12, what is the name of the brightest white dwarf? The white dwarfs are found over here on the chart. The one with the highest luminosity is known as 40 Eridani b. Number 13, name two supergiants. The supergiants are listed on the top of the chart over here. They include Rigel, Deneb, and Betelgeuse. Number 14, name one very young star on the chart. Stars that are in the early stage of their evolution are considered to be young stars. Sirius, Alpha Centauri, the Sun, Barnard star, or Proxima Centauri. Number 15. How can 40 Eridani b be so much hotter than Betelgeuse, but also much less bright? Eridani b is a small star, very hot. Betelgeuse is a large star, which is very cool. Because Eridani b is so much smaller, even though it's hotter, it does not emit as much light. Small stars emit less light than large stars. According to the luminosity and temperature of stars' Earth science reference table, the Sun is classified as. On the chart, the Sun's located here. It's classified as a main sequence star. To find its temperature, drawing a line straight down from the Sun, we find that its temperature is slightly less than 6,000, and its luminosity is 1. Number 2, which star is cooler and many times brighter than the Earth's Sun? The star Rigel is found here. Its temperature indicates that it's hotter than our Sun. The star Betelgeuse is right here. It's cooler, and it indicates on the chart that it's many times brighter than our Sun. We can rule out Barnard's star because it's cooler, but not as bright. And we can rule out Sirius because it's hotter and brighter. Number 3, stars are believed to undergo evolutionary changes over millions of years. The flowchart below shows stages of the predicted changes in the Sun. According to the luminosity and temperature of stars' Earth science reference table, in the flowchart below, the Sun will become. The Sun is in its early stage. As it gets older, it will evolve into a supergiant, which is in the intermediate stage, and then into a white dwarf, which is in its late stage. When the Sun becomes a supergiant, it will become brighter in its intermediate stage, and then it will become dimmer in its late stage. It will become cooler and brighter when it becomes a supergiant, and when it becomes a white dwarf, it will become smaller but hotter. It will become less bright, dimmer, and hotter.